All right, so the first one asks for average rate of change. What does that mean? So regular old algebra 1 slope. Do not be too proud to write out your points. We need a point -2 something and 1 something. How do you get the somethings? All right, plug them in. So if you plug in -2, that'll be 4. -8 would be -4. -7 would be -11. Do we agree? Did I do that right in my head? Okay. It's a bummer when you make a mistake doing that. All right, and then plugging in 1. 1 plus 4 is 5. -7 is -2. And then you're going to set up your difference quotient. It would be -2 minus -11, so plus 11. And then 1 minus -2, so 1 plus 2. If it's free response, what do? You're finished. Leave it. You're done. If it's free response, you're done. But you know, half the test is multiple choice. So let's pretend it was multiple choice and that you had to keep going, because that won't be an answer choice. It would be 9/3, and then you would get 3. So if it's multiple choice, you have to keep going. But if it's free response, please stop like you did on your quiz. Because if you just somehow add wrong, it's going to be wrong. All right, average rate of change. Same thing for this one. Don't be too proud to write out your points. But Ms. Cole, they're in the table. I know. I'm telling you from experience, it helps if you just write them. Okay. -1 gives you 7. 4 gives you 2. And then set up your difference quotient. So 2 minus 7/4 plus 1. Again, free response, you're finished. If it's multiple choice, keep going. So that would be -5/6. 5. Oh my gosh, do you see what I just did because I'm brain dead and it's Friday? If it was free response, actually, I'm kind of happy that happened. If it was free response, even though I have that written correctly, if I wrote a -5/6 there, I fail to earn the point. They don't do half points. They will simply not give it to you. I'm just letting you know. So actually, that would reduce further. -5/5 to be -1. That was kind of embarrassing, but that's happened to all of us, so whatever. It's just when I make mistakes, it's in front of a whole group of people, so I have to learn how to like move forward in it. Okay, average rate of change on an interval 0 to something that we're calling k is, so it's like you have the answer, you're just going to sort of do the setup, write an equation that could find k. All right, in the numerator here, they were numbers. You did 2 minus 7, but it was, you know, f of 4 minus f of -1. We're just going to write it out like the in general format. So it would be f of k minus what? F of 0, good, over k minus 0. And then we're just going to say that equals 1.07. And that in its entirety is the answer. It was just the setup. Yeah, that's all that is. But that's hard because it looks weird. And it's like there's no numbers. Except 0. All right, this one's piecewise, but you still do the same thing. We want an average rate of change. That just means slope from 1 to 3. Now you just have to be careful which pieces of the function you plug into. Which piece is 1 going to get plugged into? Yeah, the first one. So if we plug in 1 there, we would get 1. And then 3 is bigger than 2, so you would plug in 3 here. What would that be? 8 minus 12. -4. I almost wrote -12. Jeez Louise, you guys are gonna have to keep your eye on me today. All right, and then set up your difference quotient. -4 minus 1 over 3 minus 1. If it's free response, stop. But if it's multiple choice, you have to keep going. -5/2. Hanging in there so far? All right. Did 1, 2, and 4 go okay? Yeah. Okay, and 3 was just a little weird with the how you write it. All right, so we're doing good so far. Doing well. Okay. All right, now this is just for how many values of A. So it's just total, how many are there? Is the average rate of change equal to 0? 0 means horizontal line. So starting at -5, so starting here, if I draw in a horizontal line, how many different points could I connect to make that work? Yeah, 2, right here and right here. So we're just going to write out our average rate of change, kind of like we did in number 3, because it says give a reason. So it would be f of A minus what? It was just like we did with the other one. Here, let me flip back to it. See how it was f of k minus f of 0? This one's just not 0. And it's not k, they chose a as the letter of the alphabet. So f of, where'd we start? Yeah, this is our interval right here. Over, good, a minus -5. You could write minus -5. That equals 0 at 2 values of a. Which is a really fancy way of saying I can connect a horizontal line at 2 different places. So if you were to connect from here to here, that's one of them. And if you were to connect from there to there, that's the other one. So your slope is 0 at 2 values of a. I realized writing it was weird, but it's not like a hard problem. Again, how many times have I said this? The math we actually do is not all that difficult. What's hard is the directions, basically, and the notation of how you write everything. All right, number 6, using that same graph. So I'm reusing that. I did that so I didn't have to put another graph on here. Using that same graph, is there, so this is like a yes or a no kind of question. Is there a value of a, or is there a value? Sorry, I was repeating a up there. From -6 to 2, so, or -6 to -2. So we're just looking at this part of it where this equals 0. Well, you have to know what this means. So what does that mean? Good. Okay, you guys are awesome. That means derivative, slope of a tangent line. So we're looking for, is there a place where you would have a 0 slope tangent line on this interval? So is there one? Yes, watch me point to it. Do you see how right here you can draw in a 0 slope? Do you remember the matching activity you did with the derivative graphs and put on those in there? Okay, so critical points. So yes, we would say derivative equals 0 at x equals, let's just say where it was. What x value was that? -4. Good. Derivative is 0 at x equals -. What'd you put?
We put the -4, but we just didn't get the notation.
Right, okay. Well, instead of writing this, you could write the word derivative. You could say the derivative is 0 at x equals -4. Now, I threw these on here. There isn't a question on the test that directly aligns with this, but you have to know all your notation, so I threw it on here. Notation that stands for a derivative. So you have f prime of x, or you could have y prime, and then the other one is dy dx. So those are all things that mean derivative. So when you see one of those, you have to know that that means derivative, rate of change, instantaneous rate of change. And then we had 2 definitions for a derivative. One was just in general, and the other was at a specific point. All right. So the first one, limit as h goes to 0, and then what's the first step? F of x plus 8. Plug in x plus h, and then minus the function over h. That gives you the derivative. So you would end up with something with an x in it. So like 3x plus 7 or 2x minus 1 or whatever have you. The other one gives you a numeric value. You're finding the derivative at a particular point. So instead of having to get the derivative and then plug something in, you kind of skip that step. Its limit as x goes to c. C would be a number. So you'd have like limit as x goes to 1 or something like that. And do you remember how that one?
I remember the plot.
What is the denominator?
X minus c.
Good.
Is it f of x minus x?
Yes, it is. See, if I cover this up, algebra, calculus. That's algebra. Now it's calculus. So it's a slope with a limit in front of it. All right. And again, there isn't a question that directly aligns to that, but you have to know all those things, all those notational things. So I threw them on here on the study guide. Okay. So for this function, find f prime of 0. In order to be differentiable, the function also has to be continuous. So let's see it first if the 2 pieces match up. Because if they don't, we don't even have to do anything else. Like if it doesn't meet up, then we're just out of luck. All right. So we're going to do limit x goes to 0 from the left. Limit as x goes to 0 from the right. From the left, you would use the first piece of the function, and from the right, you would use the second piece of the function. So we're not even looking at derivative yet. We're just looking at continuity. Do the 2 sides link up? Because if they don't, then you don't have to do any more work, right? Essentially, you're just plugging in 0. You just have to write your notation to get credit on free response problems. If you plug in 0 to this first one, what do you get? -7, right? And if you plug in 0 to this one, 5. So do they link up? No. So the function's not continuous. And so it also isn't differentiable. So you can't get a derivative there. So you would say f prime of 0 does not exist. Hey, Ms. Cole, what if they did link up? Well, then you would go and do your limit as x goes to 0 from the left, limit as x goes to 0 from the right of the slope. We're going to do ones like that on here. So we're going to cover that. Like if say these did come out the same, then you would have to go further and do this and check from the left and from the right. Let's keep going and I'll just finish this page and then I'll stop talking again. You guys can have some more time to work. All right, function represents a car driving away from home. We have miles and we have hours, so just be aware of your units. Whenever there's units given, you should put units in your answer. Approximate the derivative at 2. What gets people on this is you're not actually going to use the 2 itself. If you want to approximate a derivative at 2, you're going to use the points on either side. Do you remember Alice goes for a walk? Oh, yeah. I bring it up constantly. Do you remember how we wanted to estimate the derivative at that point? We took points on either side and kept moving them closer. Yeah. Okay, so we're going to use these 2. So you use the ones on either side as close as you can to estimate. Don't be too proud to write them out as ordered pairs. But Ms. Cole, they're right there. I know, but I'm telling you from experience, people mess it up. So write them. If you get your test back and miss that, you're going to be very upset. I'm trying to avoid people being upset. All right, so set up your difference quotient. It'll be 160 minus 45 over 3 minus 1. If it's free response, you're done. If it's multiple choice, you do have to keep going. So let's keep going. What would we have in the numerator? That'd be 115 over 2. That doesn't reduce, so we can just leave it like that. And then I think there was another part to this. Go back and read the directions. We got a numeric answer, but what else do we have to do? Interpret. So we found an estimation of a derivative. What does that mean? Like, what did we find? Remember Alice going for the walk. Think back to that. You're going to need a miles per hour is going to have to be in there. Was this about a car? Car driving. So we'll say the car, something about the car. The car is like the noun of our sentence. Is traveling, or the car, yeah, we'll go with is traveling. The car is traveling. Yeah, 115 over 2 miles per hour. And you need to say one other thing in order to get full credit for it. At 2 hours. At time 2 hours. Approximately, it was an estimation. The car is traveling 115 over 2 miles per hour at time 2 hours. Sweet. You guys got that. It was nice. And we wrote a sentence. See, you outlived through justifying. Oh, go ahead.
I just had a question. You use the at symbol in the example.
They accept that. Okay. And they accept because B/C. They accept between B/W. They don't, I think, take, you know how I wrote AROC for average rate of change and IR? I don't think they would do that, but they take a lot of other abbreviations. Yeah. Because I use the at symbol for just about all of it. Oh, go ahead. No, of course they're not going to tell you exactly what they accept and don't accept. Why on earth would they do that? Yeah. Just like become a mind reader. No, they won't. I'm so sorry. I wasn't trying to be silly. They fucked them. I'll tell you. I try to be like as transparent as I can because I want you to do well. All right. So we'll finish 10 and 11 and then I'll stop talking at you. All right. Use the graph to the right and the tangent line that's drawn in f prime of 2. That means derivative, and derivative means slope of a tangent line. So all they are asking for literally is what is the slope of this line? Oh, but they do want a numeric answer. You're right, it's less than 0. It'll be negative something, but find like some specific points and like count the little boxes like you did in algebra 1. Yeah, it goes down 2 over 1, so -2. That's it. All right, and then we'll do 11. Let f of 0 equals 7. That means you have the point 0, 7. Again, don't be too proud to write that out. I'm telling you, it helps when you write it as a point. F of 0 equals 7 means you have the point 0, 7. Using the graph of the derivative, so this is a derivative graph. What is a tangent line equation? Oh, to write an equation, you need two things. What are they? You need a point, good, and you need a slope. Slope comes from derivative, and they gave you a graph of the derivative right there. Isn't that handy? They can't give you an undoable problem, so they're going to give you everything you need. So we need the derivative at 0. So what is that point on the graph? 0, 3. Your slope is 3. And then you just put it all together. It would be y minus 7, good, equals 3 x minus 0. I would just go ahead and write that out. I know, but it's 0. I would just leave it. It's the format of the equation. I would just write the whole thing out. Yeah, well, it's not worth making a mistake. I feel like if you just are always in the habit of writing the whole thing, you're, less likely to make a mistake. All right, so for number 12, let me draw a picture so you can see what's going on. Say this was your graph. I have no idea what the graph looks like because they didn't give me a graph and they just said the function f of x. So the function could be literally anything, but I just drew a parabola. So you have a tangent line. So here's our point of tangency that comes through, and the slope of that line is -4. So that's why I drew it going downwards. Okay, so evaluate the following. F of 1. The point of tangency is the only point that the graph of f and f prime share in common. Or the tangent line, I'm sorry. The graph of f and the graph of the tangent line, they share that in common. So all you have to do is take 1 and plug it in for x. It's an input-output thing. So if you plug in 1, what do you get? -2. Good. This is derivative. That means slope. What's the slope? -4. That's the answer. If you did more work and like the whole thing, you would eventually get there, but that's all we were looking for is just good old-fashioned slope.
Yeah, we did
That's what I would.
All right, here, f of -2 equals 7. All right, that means you have the point -2, 7. Write it out. It says write an equation. So you need a point and a slope. Slope comes from derivative. Oh my gosh, they gave us this handy derivative table. We need the derivative at -2. So what would that be? 8. It's the exact same thing we did in number 11. Just instead of looking at a graph, you're looking at a table. It's the same exact problem. All right, so that's your point and your slope. Put it all together. It'll be y minus 7 equals 8 x plus 2. Cool. All right, 14. A differentiable function has the property that f of 3 equals 9. So you have the point 3, 9. Derivative is 3/5. Derivative means slope. So it's the exact same thing we just did, except they handed you the number. You didn't even have to look at a table. Now we're going to estimate f of 3.1. Why are we allowed to estimate 3.1? Really close to 3. Your point of tangency is 3, okay? So y minus 9 equals 3/5, parenthesis, x minus 3. And all you have to do is plug in 3.1, use a wiggly equals, and you do have to get the y by itself, so you would have to put the plus 9 on the other side. So it's y is approximately 3/5 times 3.1 minus 3, and then add over the 9. Yeah, now if you had to go for, let's say it was multiple choice and you had to go further. 3.1 minus 3 would be 0.1. That would be 1/10. Did you come with me there? 0.1 means 1/10. So you would have 3/5 times 1/10 plus 9. What would that be? 3/50ths plus, oh my gosh, how many 50ths is 9? I'm regretting this. 450. So 453 50ths if you had to. Let me talk you through how I did that. Look, 0.1 means 1/10. And that just multiplied. 3 times 1 is 3, 5 times 10 is 50. That was the only kind of hard part, but 9 times 5 is 45. Throw a 0 in there. And then add them together. If I made you do that, could you? I mean, if it was on multiple choice, and you'd had to get from there to there, you'd have to figure it out. All right.
I wouldn't be happy about it. Right?
You would, okay, I'll take that. No, that your feelings are valid. I'll take that. All right. Now, again, there's not a question that like is a sibling pair to this one exactly, but there are graphs like where is the function continuous but not differentiable. So you have to know what this means. 3 ways a function can be not differentiable. What have you got? A sharp edge. So a corner or a cusp. Not continuous. Good. People forget about the third one, but the reason you can't have a vertical tangent line is what is the slope of a vertical line? But yeah, like by definition, it is undefined, but people do forget about that one, so maybe put a star next to it. But if it's not continuous, you can't get a derivative. That goes over well. And sharp edge, everybody remembers, but vertical tangent line, people tend to forget about. All right, and then we'll do 16 and we'll end there. If a function is differentiable at x equals c, true or false for the following statement. I was trying to make this like one of those ones that's Roman numeral 1 is this, Roman numeral 2 is this, and then your answer choices are 1 and 3 or 1 only. Do you know what I'm talking about? Okay, I was trying to model that here. We're just going to do true and false for each of these. So if you are differentiable, is there a point there? Yes, true. If you're differentiable, is there a derivative? Yeah, that's kind of like the definition. Differentiable means you can get a derivative. Now, if you're differentiable, you can get a first derivative, but could you get a second derivative? No. Or there's like not enough information to figure that out yet, but you would have to have a point. You'd have to have continuity and you'd have to be able to get a derivative. Go ahead.
So the second approximate,
A second derivative. We haven't gotten to that yet, but I'd like to throw it in there and bring it up. Has anyone taken or is in physics? So a first derivative is velocity, a second derivative is acceleration. It's just a rate of change, is all that is. So.
You don't have that